Not live on YouTube, am I? Calc 3, yeah. I'm not the best with it, but I should be able to figure it out. I'm a genius? Oh no. Nothing makes me feel more stupid than doing the stream. Ugh. Uh, yeah, we should be able to figure that out. These are fun. You have the solution. Okay, so if you want, tell me like what was their substitution that they did here? Because I could play with it for myself, but if you want to hear exactly how they did it, that's probably the best thing. Okay, so they took y equal to x cubed plus x. That's an interesting choice. So if x is going to 0, then x cubed plus x is also going to 0. Trying to figure out what else they did. Okay. So basically, we take the y that we have there, and we plug in x cubed plus x, minding our parentheses. Well, you normally need to do two different, because you need to get two different results from different paths. So there should be a second one somewhere in there. There are some tricky things you can do to basically do it with one sub, but this wouldn't be it. We can still see what we get from this one, though, and then... Oh, okay. Yeah, we could take x equal to 0 or even y equal to 0. Let's see what we get from this. We get the limit. I don't want to repeat the entire thing, but like the same thing over here, just transfer over y equals 0. Okay. Of x squared over minus x cubed. And so it's going to be the limit of basically minus 1 over x. And so as x goes to 0, this thing goes to negative infinity. So when I get anything that's not negative infinity from another path, we're in business. So if we take y equal to 0, let's see what happens there. We get the limit with the same thing as whatever right before it of just x, right? And this goes to 0. So yeah, the fact that from one direction we get minus infinity and from another direction we get 0 means that the limit can't exist, because it should have to agree in all directions. Or like along all paths is a better word, better phrase. It's a really weird choice. It does not... I can see the logic in it where it the plus x piece exists to cancel with the x that's originally there, and they choose the x cubed to make sure we end up with just an x in the denominator. So it is carefully engineered, but it is difficult to spot that. It's worth investigating if we can find a different sub that feels to me more natural. I think y equals x, as you're saying, Might just do the trick here. Let's try that. Well, that's a little bit weird, isn't it? Maybe that's not a good substitution. We can't allow y equals x. Uh, okay. Um, yeah, so I was thinking that because it's a limit, it'd be okay if we're dividing by 0, but we haven't taken the limit yet, so we can't even do the substitution in the first place. Um, and if we let x equal 0 instead, we still get. Oh wait. Well, what does happen? No, we get 0, so that's not helpful. Um, so yeah, since like the standard ones that I always try are letting x be 0, let y be 0, and then let y equals x. And since those have failed to get us two different things, then we do have to start thinking of trickier things. I probably would have tried x squared next. What happens here, though? We get... No, we just get 0 from that. That's funny. If we did just x cubed, like, is that plus x even necessary? It is, because we have to get rid of the 1 minus. So we could even have done... maybe x comma x squared plus x, and this might get us a different result here. X squared over x squared, and that just comes out to be 1. I'm gonna get docked points for not remembering my limit, but... So we didn't have to go as high as x cubed. You can choose anything, or can you choose anything for x and anything for y as long as x doesn't equal y here? Yes. As long as you're not like breaking any rules of math, like dividing by 0 or taking the square root of a negative, you can do any substitution you want. And so let's take some trial and error. So like if from trying this sub, you can notice that this one kind of messed up the thing that we wanted, which was to cancel the x's. And so you can fix that by doing x squared plus x. It's kind of interesting. Like you don't have to go as far as x cubed, but that also works. Seems stuff like 2x. Oh yeah, so I tend to try substituting things on y because that's just kind of how I was taught. But you can absolutely put x in terms of y. So we could also have tried I don't know what helpful sub for y would be, but like y squared comma y. You can even sub them both and put them both in terms of t or something if you want also. I think it's more trouble than it's worth, but it is allowed. See, that would just get us 0, but You could there is another thing you can do, which is letting y equals mx. Yeah. So as soon as I got, say, to this step here, or yeah, like the I would say, like, if I was doing this problem naturally, the thing that's kind of like I would have tried first is this to get 0, and then I'd look for anything else. Thank you for the follow. And then I'd look for anything else that gets me not 0. And so after trying x squared and getting 0, I that seems like it has something to it, but this -1 was messing things up, so I modified that to be x squared plus x, and that got 1. And that's probably how I would have done this one blind. Um, but yeah, at this point, I'm just kind of like trying like different types of subs just to see if we get anything like interesting. So I've seen this idea for a sub before, y equals mx, where m is just some real number. In this case, we can't allow 0. Oh, sorry, we can't allow 1 because of what we said before. We can't let y equals x. But what this does is you basically check along every line in every direction. And the thing, you should always get the same number. Like, it should not depend on m, is the point. Now, this isn't like all this does is prove that no line will get you what you want, besides maybe x equals 0, which this doesn't check for. Um, but it's kind of cool that you can check every one of your case in one go. If we did this sub, it's x squared over x minus mx. And here, if we cancel the x, we get x over 1 minus m. And then when we let, oh my god, I keep forgetting my limit. When we let x actually go to 0, we end up just with 0. So, hey, programming. So for any line you want to try, you're always going to get 0, except, y equals x and x equals 0, which we didn't check with this, but it's kind of like a neat thing. If you took the limit and still ended up with something involving m, like if you somehow end up like 1 over 1 minus m, then you say the limit does not exist because you can get different numbers depending on m. Yeah, it's like a neat thing, I think. I definitely seen you before programming with RC Ready. I don't remember you being my first sub, though. Either way, though, I'm glad to have you. Midterms in an hour. Oh, wow. Good luck. Oh, I mean, yeah, and you weren't my first viewer or my first sub, and uh, I remember banning you, to be honest. You absolutely did do something. You gave me shit every time I couldn't immediately do your problem. So I'm okay. We'll keep it there. 5 hours to finish an E and M exam. Jeez. I that's a long exam. Was it like online or like usually they don't allow you that much time for exams? Yeah, program with RC ready. That's just a lie, and I'm done with this discussion. Allowed a maximum of 8 hours on campus. That is, why are you allowed to have exams that long? You'll just see in masochism enjoyer. That like they should at least split it up into multiple days or something. That's a ridiculous amount of time to have to focus for. It sucked the soul out of me. It would do the same for me. Not I have the problem up, but I haven't actually like been rereading. I haven't worked on the problem like at least a week, and I wasn't doing part C right. Okay, so here I was trying to use the spring potential energy from right before you cut it. Yeah, what's up, Nancy? No, this is just my own studying. Um, I saw your problem up here. Not the sucking you want, but the sucking you get. Ugh. Mm-hmm. Yeah, no, please ask your question. X minus 1 over x. Um, just because it's single variable, definitely it doesn't mean that it doesn't exist. But if it's like that, this would be zero, this would be infinity. So zero minus infinity is minus infinity. Give me them points. Yeah, he said, never mind, I'll move on. But with those like multi-variable variables, the entire point is to make them single variable, so they're easier to deal with. Oh, really? Okay. Okay, maybe the issue. So I think I was worried about the bounds of this integral. So I could see I was drawing a little like number line here because the x1 and x2 kind of are going to have opposite signs here. So I wonder if the way that we assure ourselves of what we want here is to use some absolute values, and I guess we need to make the upper bound like that. I mean, I guess we only, if I'm defining x1 to be positive, we don't need all these absolute values. Sure, 750? Clean your phone. Uh, I guess in general, I don't, I don't have a clean phone channel. Oh no. No. Why would you do that? That I'll show it. I hate even like looking at this. Just dunking it. Is that like in a bathtub as well? Wait, what's the other one? Oh my god, in the shower? No, no. I'm not. Why, why would you do that to your phone? Well, please tell me it was already bricked or something. It's not clean unless you use soap. Yeah, I think 750 might actually take you up on that. Oh my god. I don't want to watch this anymore. I hate them. Oh, they're just giving you know a really weird like function just to be weird here. Directional derivative of f. Um, it's time to shill for Paul's online notes here. Because I don't remember the exact way to do them either. I think you get the gradient and you dot it with the unit vector. Hey, famished. It is a gradient dot with the unit vector. Okay. The reason that you want to make it the unit vector is that um, the dot product of two vectors is you have u dot v. That's equal to the magnitude of u times the magnitude of v times the angle between them. We want the directional derivative of the function just in a certain direction. And the issue is that you could scale this vector up or down and get different results depending on how big it's scaled. Like if I made this vector instead 300i minus 400j, the directional derivative is going to look huge because it's in the same direction, but it's like scaled way the hell up. So to like kind of standardize everything, we make it all unit vectors. And the thing that makes it parallel is actually also the dot product. Woohoo, hey! How are you doing? The dot product basically gets you the component of the like actually let me make sure I'm not gonna misspeak here. If this is u and this is v, and importantly v has length 1, I'm doing good too, thanks for asking. I just drank some green tea with jasmine. And it was very nice. Okay, right. I'm not gonna misspeak here. Jasmine, yeah, exactly, Jed. It's a new one every week. So if v has magnitude 1, as in it's a unit vector, then u dot v is just the magnitude of u times cosine theta. But the magnitude of u is just the hypotenuse of this right triangle here. And cosine is adjacent over hypotenuse. So u dot v gives you the component, it gives you the magnitude of the component of u that's parallel to v, I believe. And so that's kind of what makes it parallel. Like the dot product is helpful for telling in general like how parallel two vectors are. intervene? Yeah, Zach. I remember you do hate dot and cross product, right? Well, blame normal Calc 3, like teaching, I guess. It's never my fault, by the way. It's always everyone else's fault. Hope you're doing well. But yeah, so blame Jed, yeah, that too. But importantly, this line of logic only works if the magnitude of v is 1. Like, in going from this step to this step, v was just 1. If v isn't 1, then there's still an interpretation there, but I don't remember exactly how it goes. So I guess it's just vector per projection at that point. But yeah, but this part where I'm getting a little bit like table flipping. That's the part where my memory is getting a little bit like fuzzy right now. I have to like look it up. But to actually do the question here, I guess we want to get the gradient of f first. So, well, I guess if we're using I and j here, we can use I and j notation for the gradient. So the gradient is the partial with respect to x in the x direction. The partial with respect to x of this thing is a pain. We have a dot product, or sorry, we have a product rule there. I guess, cosine goes to minus sine, and then because of chain rule, we'll get a y out front. Then minus y over x from the y ln x, and then the 2x becomes 2, and the 4 goes away. Then plus the partial with respect to y in the j direction. So this has a y in it. The x comes out front because of the chain rule. We need a negative in front because of cosine, coming sine. And then this becomes just ln x. And then the rest goes to 0. So that's our gradient. Now we need to evaluate it at the given point, 2, 0. So cosine of 0 is 1. I don't care what any of this is. I just know we have an x and no, we have a y in front, and y is 0, so that's 0. That's 0 plus 2. Sine of 0 is 0, so that zeroes out. Ln of 1, ln of 2, that's just a number. So we get 3i hat minus ln 2j hat. That's a vector, believe it or not. And now we just need to get the unit version of that vector there. I'll call it v. So when you get the magnitude, and if you know your Pythagorean triples, you can just see that it's 5. But the way that you would, if you don't know that 3, 4, 5 is a triple, you do the square root of 3 squared plus 4 squared, and you get square root of 25. Okay, so that means the unit vector v hat is 3 over 5 I hat minus 4 over 5 j hat. And now we do del of f of 2, 0 dot v hat. And that's our answer. Or if you're Zach, you inner producted. So we get 9 over 5i, I guess, plus 4 over 5 ln 2 j hat. No worries. I guess so, sure. Oh, it's interesting that. Hey, $10. Oh, really? So we're specifically looking at this portion right here. Um, and I I guess it's a convention. Yeah, this is a weird one, Zach. Um, because I would have like I did in the problem. I called this negative infinity, which isn't a number. To be fair. Um, but if you do chalk it up to limit not existing, then yeah, you only need to find one direction where the limit doesn't exist in order to say the limit overall doesn't exist. Um, yeah, I feel like you're missing out on information though, because like, what if it goes to negative infinity in all directions? That's still some helpful insight that you're not getting if you just call it does not exist. Yeah, that it does seem like what's happening here, Nancy Meow Meow. I it feels a little bit weird to me because like if the function, just to give a a simpler example, like it would be like if you have a function that looks like this, as soon as you show that on one end it goes off to negative infinity here, you would just quit and say the limit doesn't exist. I feel like you're not learning all you can about the function because this branch over here goes up to positive infinity, and that just feels like it's helpful to know, but or if you just it's not wrong. It just feels like it's not as complete as it could be to me. If x goes to 0, there's an asymptote. Yeah. Did we ever... I don't see this in this work ever taking x going to 0 though. Or I mean, besides like I only see like one piece of the you what am I trying to say? Where are you getting positive infinity from, Zach, I guess? If x goes to 0. But yeah, that goes to negative infinity though, does it not? Or like the overall limit goes to negative infinity. Only from the right. Oh, if x is negative. Oh my, it's literally the example. I drew the exact thing. Huh. I literally, I thought I was pulling this out of nowhere, but I unintentionally drew the exact function there. um, okay, so I think what's actually happening here, Nancy, then, is that um, I was incorrect to conclude that the limit of -1 over x as like me saying this was minus infinity is wrong. Hey, Stelly. Uh, because I'm only right if I'm coming from the right hand side. That this limit actually does not exist because of the exact thing I drew here. Like the positive side goes to negative infinity, the negative side goes to positive infinity. That's why it's DNE. This is like a true DNE. It's not just like, yeah. So like in my head, I thought we had a graph that looked like this, I guess, where both sides go to negative infinity, and I thought it'd be weird to call this DNE. Can I read that one more time? So I was wrong to say limit as x goes to 0 of -1 over x is equal to negative infinity. This is not a true statement. Because basically, yeah, Nancy. Or just have good intuition with plugging in or like think about positive and negatives or like where things might switch signs. Because the graph of this thing, like this limit truly does not exist as x goes to 0. Like they just go to opposite places. If it was -1 over x squared, like I drew here, that will be when it's okay to say minus infinity. But just in this one single variable limit, you get something that already has different values depending on what side you come from. And so that's why it's okay to only check this one thing. Because we happen to choose a really good path that, even in this single variable case, is already the value limit depends on what path you approach from, the right or the left. Oh yeah, and so as Zach is saying, you could try plugging in very small values of x, negative and positive, and think about what happens. So a very small positive number becomes a very big negative number. A very small negative number becomes a very big positive number. Is how you would think about that one. Okay, so yeah, that's my bad about being critical of that. Yeah, no worries. Thank you for the question. That's funny. Like that's another example of like types of questions coming in waves. I was just hanging out in Obi's chat yesterday and Punching asked a multivariable limit question. And the first question today is another like multivariable limit. Yeah, sure. Lucas, what's up? Yeah, go for it. Wait, no, yeah, I guess I did find. Is this a positive number? I guess gravity is negative. Mm. Yeah, good luck with. Good luck, Nancy. Hope your midterm goes well. And hey, account over on YouTube. Good skill. There you go. Oh, I guess I'll just copy this. You self sympathize a question for your entry exams. Oh wow. Yeah, I'm still having troubles with that one. That's just on screen, but we're moving to a question from Lucas here. JE. Oh yeah, I've heard of those. Those exams seem very difficult. Okay, so the question is, what does x plus y equal given x times y is minus 2. Oh, what is this? X cubed plus y cubed. Cubed? Are those nines? Okay, it's a daily question. First, you got a root of minus 4, then you got 0. Well, uh, I guess I want to look at the left-hand side. What happens when you expand this? Ignoring this part. Academy of Useless Ideas, thank you so much for the raid. How's your stream? Everyone here on my end, please do check him out. Super interesting stream, telling like the story of math. And talk about like math, philosophy, and stuff like that. Hope it went well. Okay, so we're just working on this problem here from Lucas in chat. We need to figure out what x plus y equals given this information here. And so in order for this statement to be true, we must have the middle terms here be equal to 0. And our stream with karaoke. Oh, I guess I can't use a lot of it twice, can I? Oh, and Megalomorph has the better arrangement of this. Any requests for the karaoke song? Oops. The Fresh Prince theme song? Oh, I could, but I need to see if I can find the lyrics for it, because I hardly watch that show, so I don't know it very well. I'm sure there's one out there like that. Let's just get through this question and oh wow, Jed is on the ball. Uh, Lucas, I basically, well, I don't know. Does this actually help us? Um, Life got flipped and turned upside down. Yeah. I took these middle two terms and I factored out a 3, an x cubed, and a y cubed. And so all I had left over was x cubed plus y cubed. But um, Jed's tables got flipped upside down. Oh wait, I count saying is the answer 2? I'm not sure yet. Well, I mean, we know this entire thing has to be equal to 0. And we know that if xy is negative 2, x cubed y cubed is negative 8. If we cube each side. Yeah, we may as well get rid of the negative 24. But like, what does this tell us? I guess we can plug it in. We know that x cubed is now negative y cubed. And if xy equals 2, we can sub it in here. So xy equals negative 2 become... Well, I guess we want to sub it in here, don't we? Well, it doesn't matter. Let's do the... If x equals negative y cubed, then x equals negative y if you cube root each side. Oh, that's not good. Oh, no, yes, it is good. So if x equals negative y, then we get negative y times y is negative 2. So y squared is 2. So then y is root 2, and that means x must be minus root 2. So x plus y is 0? Actually, I didn't need to even go this far. As soon as I got to this step, couldn't I have said that this is 0? Well, because this step combined with this step. Okay, can I verify? Well, it is a dumb answer. It checks out with these conditions, though. Like, it minus root 2 and plus root 2, you get 0 equals 0, but that's true. And it meets that. This does feel lame. I don't know what else it could be, though. I don't know if anyone spots an error in my work, but it might be fresh printing time. You have class? All right, Mega. Thanks for the guidance. But before it's been too long though, I guess we'll do the karaoke. Let me. It's gonna be even like really weird for anyone who's watching on YouTube because you're not gonna hear the music. So it's gonna be just me singing, but that's your problem. Oh hey, and even the lyrics are just right here. This is a story all about how I don't know how it goes upside down. And I like to take a minute, just sit right there, and I'll tell you how it became the tech. This is terrible. The quality also. It's been so long since I've watched the show. Do the Carlton. In West Philadelphia, born and raised, on the playground was where I spent most of my days. Chilling out, maxing, relaxing, all cool, and all shooting some b-ball outside of the school. A couple of guys, they were up to no good, started making trouble in my neighborhood. Got in one little fight, my mom got scared and said, "You move with your auntie in Bel Air." Fuck. I'm embarrassing myself, but fuck it. Give a kiss, and then she gave me my ticket, put Walkman on, and said, "Might as well kick it." First class. Yo, this is bad. Here's out of a champagne glass. Is that what people of Bel Air living like? This might be alright. The Pepsi, booze and wine, all that. Dude, I can't even. I'm two in my head for the Fresh Prince of Bel Air. Oh my god. I never done karaoke sober. This is a lot harder. Plane landed, and when I came out, there's a dude looked like a cop standing there with my name out. Ain't trying to get arrested yet, just got here. Spring with quickness like lightning disappeared. Whistled for a cab, and when it came near, the license plate said fresh and had a dice in the mirror. If anything, I could say this cab was rare, and I thought, ah, forget it, yo, home's to Bel Air. Oh, really? To us, I only ever watched a couple episodes of the show in the first place. I'm sorry, guys, this is bad. I I at least tried. Ugh. I know Central. Um, I don't think I have it in me to yeah, it doesn't go anywhere for me either. No worries. Thank you. Because that is a fun idea. There we go. Oh, you sure want it? Because yeah, the Wolfmouth is like the Wolfmouth links tend to like glitch out. Um. Oh, is this gonna tell us what x plus y is? I mean, I definitely know that root two and minus root two are right, but well, I guess these are there's only two real solutions. The rest are imaginary. Yeah. It's basically they're not really they're not really showing it, but wait, what? This is it's a weird graph, but basically xy equals minus two forms the blue parts of the graph here, and the other requirement, the x cubed plus y cubed cubed, form apparently the gold parts, which seem weird, but it's wherever they intersect our solutions. There's only those two intersections that it's showing us at least. I think this one's a better representation. Okay, well, I feel a lot more sure that x plus y equals 0 now. Why does this graph look like this? It's so weird. Assuming we're not allowing for complex solutions. Well, I mean, what did Mega say? Let's go down that path too, but I think 0 is just the right answer. So if you factor x cubed plus y cubed with the sum of two cubes, you get x plus y squared minus xy plus y squared. And then you also that second inequality doesn't seem quite right. Or at least This can't be right. This doesn't seem good to me. I don't think it's 2xy for the sum of two cubes. No, there's no 2 there. Hey, Jaden. I'm doing well. How about you? Oh, and I paused the regular music. That's why it's so quiet. It's good to hear. Dang, I wish Mega didn't have to leave because I don't understand how you can go from this to this. Jasu, the question is, what does x plus y equal given xy is -2 and x cubed plus y cubed cubed is x to the 9 plus y to the 9? So I got that x is minus root 2, y is root 2, and so their sum is 0. And I'm pretty sure that's just the answer, like the sum is 0. Unless you allow for complex solutions. I was trying to follow different paths suggested by Megalomorph to verify that. I'm sorry to hear that, Jaden. If you have a question, let me know. Importantly, Lucas, this has a minus. Wait. Well, no, we're not starting with that though, Lucas. We're starting with x cubed plus y cubed. That's where Megalomorph's argument is starting from. So you're also right, but x cubed plus y cubed is different from x plus y cubed. Why is my journal plus plus moving so slow? But this step here is completely sketchy to me. So I'm not quite sure I understand what's going on with that, and Meg isn't here to direct me, so. I think we've done it right up here for what it's worth. Lucas, it does feel like an unsatisfying answer though. Joe Mama. And it's just for the math section on the SAT we're taking on March 8th. For my recollection of the SAT, like all the math questions were just trick questions, and if you learned what tricks they pull, the actual questions themselves weren't that hard. If you have anything you specifically want to talk about, please do let me know. And yeah, Lucas might drop a link in chat. I'd say Dr. Gold or Actual Education specifically does a lot of stuff to like prepare for the SAT. So he might have some more specific tips about like preparing for it. I haven't done anything with it since I took it like 10 years ago. Maybe even more than 10 years ago. I don't like that, that's true. But yeah, the person I'm aware of who like simply like helps people prepare for the SAT, that's probably the best person, but I can also give an actual like question you want to like look at. But I just remember them all being like trick questions. Squared on the right hand side, not cubed. That seems okay to me, then I think. Yeah. Did he write squared? No, he wrote cubed. Okay, so that's just a typo. Future admit? Oh, is that a YouTuber who does like math help? No? Oh, okay. Oh, it's a website? Or wait, I I'm confused. No, I okay. A YouTube channel. Okay. So there's that then. Just found the link. Um yeah, no worries. The last factor gives you plus or minus root 6i solutions. Um do we have to how? Do we have to cube this? Like that and equate stuff or hey Carrie Hunt. Nothing much with me. How about you? X cubed plus y cubed is 0. Oh, you're saying to get complex. Okay. Okay, so I thought this would be a way to start from scratch and do the problem differently, but if we build on the work we did before, then sure, yeah. Apparently from this realization that from what we did before, x cubed plus y cubed is 0. And so either x plus y equals 0, oops, from this piece, or from this piece, we get x plus y squared. Xy is negative 2, so plus 6 equals 0. X plus y squared equals negative 6, so x plus y is I root 6, plus or minus. I guess so. Minus I root 6 or I root minus 6? No, let me, if you have the square root of negative 6, how you deal with that is you think of it as the square root of negative 1 times 6, and you give each one of these their own. Oh, I'm sorry. If we let me start over. Just take a simple example. Like if we have x squared equals negative 6, we take the square root of each side, and we take the square root of each side. We do need our plus or minus, and to deal with the plus minus stays on the outside, but to deal with the negative square root, we can think of it as negative 1 times 6, and then exponent rules allow us to give each one their own square root. And the square root of negative 1, we've all agreed is I, basically. The plus or minus is because let me show with a simpler example still for why we need the plus or minus when we take the square root of each side. If x squared equals 4, it depends on where you're coming from, Lucas. This specifically happens when you take the square root of each side of an equation like this. So if you know that x squared equals 4, and you take the square root of each side, the correct solution is x equals plus or minus, not plus or minus 2. Because back up at this statement, if you plug in 2, you get 2 squared is 4. But you could also plug in negative 2, and negative 2 squared is also 4. That's why. If you start out knowing that x equals the square root of 4 from some other context, then yeah, you just say x is 2. But if you come from the context of x squared is equal to 4, you need the plus or minus. You're currently taking Calc Honors. Should I take AP Stat or Calculus AB or BC? Good question. Do you know what you want to do? Do you know what you want to study in college? Yeah, Carrie. I mean, unless you're given other context, the plus or minus just stays there forever. But if you're given like a physics problem or something like that, you might be able to eliminate one of them based on the context. Um, okay, so let me. If you have an equation and you take the square root of each side, you always need a plus or minus. That's just kind of like the rule. So if you have x squared equals 4 and you take the square root of each side, you need to insert a plus or minus. And it's because of the exact thing that I've shown here, which is if you know that x squared equals 4, 2 does satisfy that equation, but negative 2 also does, and you can't leave off negative 2 just for fun. It also works equally as well. So you're missing out on solutions. If you take the square root of each side of an equation and you don't do the plus or minus, you're missing out on solutions. You want to enter the business field, eventually move on to law school, become a corporate lawyer. Fair enough. I bet they're going to make you do both stats and calculus in college in that case. Just to some amount. I don't know. Do people study business need to take stats? I know they need to take calculus, usually. Hmm. I probably, if you're interested in one or the other, I would probably just do that personally. I think they're both going to be helpful for you. I personally might want to get stats just kind of out of the way and take that class. Personally, I did both AP stats and calculus BC in my last year of high school. Um, but yeah, like you think that's just like pursuing what you're interested in or getting what you're less interested in out of the way. But I think both are helpful classes for you. And if you're set on going to a specific college, it might be worth, or or if you're hoping to go to a specific college, you could try looking up what their major requirements are and what AP credits they accept if you really want to go the extra mile. Um, okay, so yeah, Lucas, I see that if you already have like I'm trying to find a oh really $10? That's funny. Um, so Lucas, the square root of 4 is just 2. Um, thanks for the follow, Joe Mama. So if this square root is already existing, you can just say that it's 2. You don't need to worry about a plus or minus. If the square root was never here in the first place, and you're adding it for yourself, like in this equation up here, that's when you need the plus or minus. And I'm seeing another explanation where if you know that x squared is equal to 4, you could also think of it as x squared minus 4 equals 0 and factor it as a difference of two squares. X plus 2x minus 2 equals 0. And this also gives you the x is minus 2, x is plus 2. It's not about what the square root of 4 is. It's about all the possibilities of x squared. So when we say that x is equal to plus or minus 2, it like, or we're saying if you take the square root of each side, we need the plus or minus, and we have x is plus or minus square root of 4. We use the fact that the square root of 4 is 2, but the plus or minus is separate from that square root. So going from this step to this step, we do use the square root of 4 is positive 2. It's just that we're not interested necessarily in x, we're interested in x squared. And the squared gets rid of negative signs. That's like the issue. Isn't the AP or isn't oh there are some freeform answers for the calculus classes, right? It's not all multiple choice. I don't remember. I don't know if Dante grade is about 1 in 6,000. Oh god. My handwriting has not changed much, so 6 free response questions. Okay. Yeah, so it's a weird thing. So if you know x equals 2 and you square each side, then yeah, x squared does equal 4. But if you erase this piece and you know that x squared equals 4 and you square root each side, then x equals plus or minus root 2. Or sorry, plus or minus 2. It's the act of square rooting each side that causes this weird plus or minus thing. Squaring each side is fine. X equals root 4. Exactly, yeah. And so there's even another way of explaining this, I guess, which is this might be a little bit extra, but it's the same weirdness that happens if you have a parabola and you take its inverse. So that's like y equals x squared. When you take the inverse of that, we say it's y equals root x, but that's only half the parabola. Like we deleted the bottom half. That's y is minus root x. And it's the exact same, like that's why this weird difficulty it exists for the exact same reason. range I can introduce false roots. That yeah, maybe we should get into to that piece, but that's also true. It is dumb. It's really awkward and annoying, and it's easy to forget. But it's the truth, unfortunately. Just erase the minus root x because you. Yeah. Functions that are bijective, yeah. And so I guess we could even say like if you cube root though, you're fine. If you to add another layer of weirdness. If you know that x cubed is 8, you can say for a fact that x is root 2, no plus or sorry, x is 2, no plus or minus needed. And that's just the weirdness coming out. Function with multiple x's. Okay. Yeah, that's a common place where you learn about range. Okay, speaking of calculus BC, I see DeViking posted a volume of revolution calc BC question in the Discord. Calculator active. It's a funny way of saying it. Yeah, it's a weird function to find an inverse for. I think you do that by completing the square. Oh no, that one's no, it's not a perfect square. But yeah, like if a function has, you know, a domain in a range, the inverse has them switched. And this table I'm making isn't like this isn't a perfectly made table. There's some subtleties here that I'm ignoring. What domain and range actually mean, but um that's kind of where the idea comes up, where the range of f becomes the domain of f inverse. Yeah, excuse me, my eraser isn't erasing. There we go. It's the autosave that's doing that, I think. Um, yeah, so if you know that y equals x squared plus 2x plus 4, you would switch the x's and the y's and then solve it for y. I don't think that's a helpful step. I like what Amanda Blam says with completing the square. So I'm going to say that 4 is the same thing as 1 plus 3. And this bit in here is a perfect square. And this is in a form where it's easier to solve for y because subtract the 3 over. Square root each side, which introduces the plus or minus. Unfortunately. Normally, you know, we just delete the minus sign for the sake of simplicity, but it is supposed to be there. That's exactly what I was saying before, where we normally say the inverse is y equals root x, but an equally valid inverse is y is minus root x for the case up here. Anytime you square root each out of an equation, you need the plus or minus. By like, people often just delete the minus sign because it's annoying, but it is supposed to be there. And so if you just want one simple thing to graph, then yeah, delete the minus, because a calculator doesn't know what to do with plus or minus. But yeah. You thought math made sense. it it kind of had to sit with me for a while before I felt like I understood it. I mean, you can go make your own type of math where that doesn't happen. You probably get to some contradiction or something though. All right, so this is a calculator allowed question. So let's set up. Well, we can even graph this with if we're allowed to use a calculator, we should use a calculator to the fullest extent, right? But let's open up Desmos. Hey, Alex, you want to integrate cosine x divided by 1 plus sine x? I think I can see how to do that question quickly, so let me do that. Since this one I'm working on right now is going to take me a minute. I'm not sure the person even here, so. Uh, cosine x over 1 plus sine x. The thing to notice is that the derivative of sine is cosine, and so we have a really convenient u sub we can do here. U is 1 plus sine x. Sorry, I should say the derivative of the entire denominator is just cosine x, not just the sine x piece. So du is cosine x dx. So this cosine cancels with that cosine, and we get 1 over u du. This integrates to ln absolute value of u plus c, and then we unsub. So it's the ln absolute value of 1 plus sine x plus c is the answer, Alex. Y equals e to the x. Oh. Integrate with natural logs. Yeah, it is a little weird. You think it should be a non-calc question, Emma? We definitely could do without a calculator, but if it's allowed, then let's use it, in my mind. Yeah, I mean, E is just a number. Lucas, it is weird where there's no actual, like, numbers. It's all just letters. So we need to rotate y equals plus 2 minus 2. X is minus 3, x is 2. Yeah, since they gave us 4 different axes, yeah, it would be mean to do that by hand. We definitely could, but it is a little mean. Yeah, I mean, I would not, I would not and could not calculate this by hand. computers just use an approximation and do powers of that. But it would be like really messed up to try and do that exactly by hand. It just wouldn't be possible. Um, dude, I gotta use the bathroom. But the idea is that we're for the first one we're thinking about y equals 2. So the farther away function is e to the x. So the radius of that, I guess, is going to be e to the x minus 2 squared plus, or no, minus root x plus 2 minus 2 squared. Or I guess we want to take the opposite, 2 minus those. Yeah, the order doesn't actually matter. What's that level of math I've taken / gone through? So I have a bachelor's in applied math. Alex, the hardest class I've taken is called, or I guess like the most, the highest level course at the college I went to was called Methods of Applied Math. It wasn't necessarily even my hardest course, but it was like the capstone course. And that was like differential equations and linear algebra. And a little bit of PDs, but I don't remember it that well. I'm gonna use the bathroom though, and we'll get an actual answer for this. Um, but I'll be right back, guys. Okay. Um, so I guess let's set up the integrals and let the calculator do it for us. I might do it just like, I think maybe I'll do one integral for y, one integral for x, and see what happens from there, though. We don't have to do every last one here. Let me get a good screenshot here too from Desmos. Oh shoot. Wait, Zach, are you still here? If not, I'll send you a message. I just want to make sure that class is still happening tonight. I think it is. Let me send him a message quick. I just sent him a DM anyway, but yeah. Oh, this is a very good one to have calculators allowed for because good luck finding these intersection points without one. um, it's probably overkill to do that many digits. Okay, so the outer will follow the purple curve, e to the x, because it's farther away from the axis. So e to the x minus 2 squared. And so that is the volume generated by this entire solid here. So what we need to do is take out the volume, the piece that we don't want, because we want the area between these two things. So how we do that is we get the entire volume, which is what I just did here, and we subtract out the piece we don't want, which is just here. And that comes from the root x plus 2, the one that's closer to our axis. And go to Wolfram for the answer. Minus 1.98. 0.448. E to the x minus 2 squared. Minus root x plus 2 minus 2. That looks suspiciously like e to the 1. Two seven one eight two eight. That's right. That's so close to being an 8. It's funny. We'll call it 2.72 though. Well, if we are we 3 3 decimal places. Truncated or rounded is acceptable. So we'll call it 2.717. Improved precision? Oh, oh, like with the bounds? Yeah, I could do that. 097. Uh, 54 or 754. Seven 717? Exactly. Huh. Sus. Yeah, something weird like that, Jed. Like, it wouldn't be possible to solve it for X on just like with pen and paper. I mean, unless you do the same calculations the calculator does with like series or however it is they actually solve that. Or Cordic, or who knows? Or it's probably like Newton's method or something like that. Or Newton-Raphson, I forget what it's called. To find a zero. Newton's method is for derivatives, right? Or is that Newton-Raphson? I don't remember. Newton has a name on too many things. No, it needs to be an actual number for X. Or for the bound. I doubt I could just give Wolfram Alpha that equation. It's not important though. Who does he think it is? Oil? Exactly. What is the one for finding zeros? Is it Newton's method? Oh wait, Newton's and Newton-Raphson are the same thing? Oh, well, okay, fuck me. It is the root finding algorithm. So yeah, you could use that one to solve the equation, but right. Oh, is it actually, ironically, it's Euler's method. That's what I was thinking for differential equations. Where you approximate the solution to a differential equation looking at the slope of the line in step sizes, right? I'm pretty sure Paulo goes over it. Yeah, Euler. Oh my god. Speaking of Euler. Okay. That's a tangent. Speaking there's multiple tangents happening, I guess. Okay. Um oh. I thought I was solving one. I realized I just solved two though, wasn't I? Wait. Yeah. Because in Desmos I put y equals 2 first by accident. So I solved case 2, I guess. Um Ode 45 in MATLAB. No, I used a lot of Quiver to make vector fields. That's the thing I remember the most in MATLAB. I had yeah, we're mostly doing like systems of differential equations. This seems like it's probably Euler's or similar to Euler's method. What happened to pi? Oh, I forgot about pi. Thank you, Jed. So now it'll be like pi times e. Are you kidding me, Wolfram? Oh wait, okay, no, it's right here. 8.536. Is it different than mine? I think it's summing these two volumes together. I I don't know that's going between these two curves. Or that's what I'm concerned about. This integral is something completely weird. I mean, I guess maybe it's simplifying it in some way, but I'm not sure this is doing what you are intending it to do. It's hard to tell. It could somehow be the same thing by some crazy way, but or this could be the correct one by some crazy way, but I don't think so. Okay, let's set up one of the ones with X. Hey, Arav, how's it going? I definitely seen a widget in Wolfram for doing it. I'm doing fine too. Thanks for asking. So I think cylindrical shells and washers, I, they look about the same to me in difficulty. We can do them both. Why not? Let's do them both. Let's start with washers. So in order to make washers work, we need to put everything in terms of y. Yeah. So, before we even start, integral, if y equals e to the x, then x equals ln y. And then if y equals root x plus 2, then x equals y squared minus 2. Yeah. So now for the integral, we need to put our bounds in y. Oh wait, I already have that on the screenshot. Why am I doing more work than needed? We'll call that 138. One, 5, 6, 4. So if x is -3, then the outer function is the ln x. The inner function is y squared minus 2. dy. And this is something, I'm sure. It's not nothing. Should be a y. One, 3, 8. 1.564. Pi. All my homies hate pi. We never put it. 15. Why is it saying that's exact? That is not exact. 15.540. Unless pi somehow cancels, but I doubt it. But we should get the same result with shells now. And I'm just doing this to show off, I guess. So shells, we keep it with x. We need a pi. Our x bounds are 198. I guess we were using just that before. 448. Okay, so it's radius times height, right? So the radius is whatever x value happens to be minus -3. Just making sure that checks out with the signs, and I think it does. Yeah, yeah. The height is now, okay, it's finally the square root's turn to be the upper function. Root x plus 2 minus e to the x dx. What does that come out to be? Do yet a third Wolfram link. No, why is this half? It's basically half of what I got in the last one. Am I missing a piece for... Oh, it's 2 pi. It's 2 pi. 2 pi RH. There we go. 15.540. It's always gratifying when they do indeed come out to be the same. Okay, let me get a screenshot of what we've done here so far, and I'll send it to the person who asked. Oops. Yeah, Rob. I can look at your question. Oh god, it's gonna be one of these. It's a fun theme. It's not just trains. Ooh, the policeman is accelerating 100 meters per minute. That sounds fast. I'm American though, so I don't have a good intuition for how far 100 meters is. It's basically a 20th of a mile. Maybe that's not that fast. A kilometer is like a little more than half a mile, right? It doesn't matter. Why am I thinking about that? Hmm. Honestly, I kind of want to graph this. Oh, maybe making a table is better. Yeah, I think I want to make a table here. That wants to call in 4 minutes. Okay. Let me make a table with 3 columns. We have time, we have thief, and we have policeman. And we're gonna look at it in 1 minute increments, I guess. Or maybe 5. Okay. So maybe let's start at time 0. I should have done that. So time 0, they both haven't moved. After the first minute, the thief has moved 100 meters. The policeman still hasn't moved. He is a minute behind. I guess the thief's column is going to be relatively easy because it's a uniform 100 meters per minute. So just take the number of minutes and multiply it by 100. So 100, 200, 300, 400, 500, 600. And so now the policeman just started running at minute 1. And so by minute 2, wait. Yeah, by minute 2, he's covered 100 meters. Now between 2 and 3, he's running 110 meters. So we add 110 to a previous game to get 210. And now we're adding 120. So that's 330. And then now we're adding 130. So we get 460. Hey, Benga. And then gonna add 140? I'm surprised we're not catching him faster. This policeman is not working hard enough. Let me tell you. So I guess we're doing 140 to get 600. Oh wait. Oh, yeah. Okay, I guess that's fine. I thought that we have to go another minute at least, but no. I guess right at the 6 minute mark is what I get. And so this is an arithmetic progression in the right column, right? Because we're adding 10 more each time. Is that what it means to be? Or is this arithmetic? Ugh. Wait. No, it is an arithmetic progression, the column on the right. I guess, well, they probably both are. No? 100. I just got the answer like by brute forcing it, basically, but if there's a nicer one, it'd be good to see. It's a sum of an arithmetic progression. That sounds more right, Axel, yeah. That's the sum of an arithmetic progression. Oh, yeah. Okay, because in like the differences, we're adding 10 each time, but we're the actual column is the sum of those. Okay. Yeah, I guess if we were trying to put it in sums, the thief would be the sum from n equals 0. Well, I guess time equals 0. Just working in discrete time at least. To some number n of 100. Hmm. That's not really capturing the 0, is it? Yeah, the answer is 6. Penmouse agrees. Okay. If we make the policeman start at t equals 2 to try to build this head start in, I think it looked like this. Could we equate these two and solve it? It's like the top one is just 100 times n. The bottom one is 100 times n minus 1. Because we're starting from t equals 2. What did... The autosave does weird... Oh, it's just... The autosave does weird things to turn plus plus while it's happening. Um, and we could figure that out. I'm curious to see if we can get the answer from these summations. So the 10, so basically, I should probably draw this out in more detail. Let me put these over here. It's the thief. Zodal squared, thank you for the follow. If I'm pronouncing that right. Let me do some few more steps to make sure I'm not being confusing about this. When you have two things added in a summation, they can each get their own summation. And this one over here, for the same reason this one was 100 times n, this will be 100 times n minus 1 because we're starting one later. So there's one less 100 in there. This 10 can come out front of the summation. So t minus 1. And now that subtraction, each one can get their own summation, but we do have to remember this 10 is out front, so we should distribute the 10. I'm drawing out each step in like the gory detail here, but if I was like doing this for my own homework, I would probably compress these steps a bit, but just in the interest of being complete here, I'm showing everything. Okay, so this is the sum of integers from 2 to n. The sum of integers from 1 to n is called, I mean, it has a couple different versions of the name, but it's basically Gauss's sum is what it's often called. If you start from k equals 1 to n of k, that is k plus 1 over 2. And so if we start from t equals 2, we can just subtract a 1 off and make that 2. Because 1 is the first term. Lubert is asking a question. Does the policeman have constant acceleration, or does his velocity have discontinuous jumps each minute? I am assuming it's discrete. Like discontinuous. 1.2k followers. Oh yeah. So I guess Twitch is being generous and rounding up. I'm at 1157 is my exact follower count. So I guess I'll take the extra little bump in followers, but either way, yeah, it does feel like it was definitely way less of a grind to go from 1,000 to 1,100. Oh, Shane. Thank you so much for the raid, Shane. Well, welcome in, everyone. Are you doing office hours? For everyone around here, I'm Don. I do math help. Working on this problem from Arav is over in the YouTube chat. It's kind of like one of those like train problems where like a train leaves one place at 8 a.m. and another train leaves another place at 10 a.m. Just mess around. Nice. I watch it for just like a little bit, but I couldn't stick around. Hey, Matt. Welcome in. Yeah, for everybody here in Miami, please do check out Shane. Awesome streamer. Streams about history and things like that. So we solved the question up top here. I did a brute force way of just making a table for The first column is time. Second column is the position of the thief. Third column is the position of the policeman. And that gets us the brute force answer, or at least that gets the answer by brute force. It should be 6 minutes. But I'm trying to find a more clever way of doing it. It'll have economics talk. Oh, interesting. Economics has always been very weird to me. I remember the economics class that I took in college. A lot of it just didn't make very much sense. It'd be cool to know more about it, but it's kind of like I have a hard time with the concepts, I guess. Sounds good, Rob. I'm still gonna work on this problem, see if I can get a more clever solution, or to see if this idea works out. But the answer is it should be 6. Right. That's so yeah, Frank, you're asking a good question here that we were just thinking about. I'm interpreting these increases as like discrete. Where like the policeman goes a constant 100 meters per minute, then suddenly jumps up to 110, then suddenly jumps up to 120. But there definitely could be a smooth curve. I don't think that's what the problem is saying, but you could interpret it that way. Social science that tries very hard to be a hard science. It's a funny way of describing it. That's my impression of it too. People learn economics are people that know economics but don't do it for a living. Ugh. Yeah, there's like some weird things. I only know a tiny bit about like the math behind economics, but like it's like what is it? The way that calculus applies to economics is very foreign to me. It kind of makes sense, but it's like something like the total cost, or if you take like the derivative of the total cost is equal to the marginal cost or something like that. I'm sure there's a way that if I put enough like thought into it, I could figure it out, but the relationships are kind of weird. And Finbox is saying, even if it was continuous, the answer could still be the same. Uh, yeah, for a line, that's probably true. Yeah, I feel like it would be. Well, but what kind of line would that have to be? It'd have to go right through the middle of the steps, right? So you get an even amount of over and under estimation. There must be such a line that exists like that, though. Arav is asking, how do I speak fluent English? I was born in America. That's how. I very badly wish I could speak another language. I don't know how non-native English speakers have like do it. Um, Economists who insist in making hard formulas that work out in all circumstances just miss the point. Then many people fall down the rabbit hole trying to justify Marx's formula from volume 2 of Capital. And to be instructive, not hard. Oh, I haven't even gone that deep in it. I could see it being like I guess stats is it like statistics is exact, but it deals with randomness, and that feels like a step even further where it deals with randomness and human behavior. Or like stats, you take some nebulous cloud of points and you can draw some like really exact line through them. But you have to remember this line isn't a perfect representation of the data. And I can see economics being that, but a step even worse. Um, okay, so with this brute force way, t equals 6, but I was trying this tricky summation way, where looking at the columns, for the thief, you're just adding 100 each time. So you could express that pretty cleanly as this summation here, and that's just 100 times n. The columns for the policeman are a little bit harder, but I think this is a good representation, and I'm trying to split that up. Thief also accelerated. This trick gave us infinite energy. Give the policeman to chase another policeman. That's the key, Frank. You're thinking big. Yeah, my idea here is to simplify both of these summations to get functions in terms of n, and then set them equal to each other, and hopefully 6 pops out the other side. So this summation here, I'm gonna say is basically this, but with t's instead of k's, because that's called Gauss's sum. So 10 times parentheses. Wait, is it plus 1 or minus 1? It's plus 1. Because you do, for 1 to 100, it's 50. No, it's 49. It's n minus 1. No, it's plus 1. Yes, okay. Because the story with Gauss's sum is that he was, I mean, it's not verified, but apparently as a kid, he was being a smartass to his teacher. And his teacher, as a punishment, told him to sum the numbers between 1 and 100. And Gauss, being a genius, figured out this formula where if you have 1 plus 2 plus 3 plus ... I'll write some of the ones in the middle because that's important. 48, 49, 50, 51, 52, ... plus 99 plus 100. You basically have pairs that add to 101. 50 plus 50 is 101. 49 plus 52 is 101, and all the way out until you get to the end at 1 plus 100. So you're actually just doing 101. Wait. Why is my explanation slightly off? You're summing 101 50 times. But you have to divide by 2 because we paired these things up. It's something like that. I may have that slightly off when I actually try to work that out in my head, but you think I got it right? Okay. I started the sentence feeling great about what I was about to say, and then when I actually started to say, it's like, am I justifying this exactly right? I have it about right, at least. I know that much. The sum of 1 from n equals 2 to, or from 2 to n, it would just be n, but we're starting from 2, so I'm going to say it's n minus 1. N squared is for odd positive integers. Oh, yeah, I've seen that before. I always forget about that. That you can make sums for a bunch of things. It's an inverse from 100 to 1 and added both series. Ooh. Oh, yeah. Oh. Yeah, if you want to get the sum of even numbers, that's right. You could think of it. No, wait. Yeah, you could think of it as two sums of 1 to 100 added together. Okay. Sorry, I'm going on all sorts of tangents, which is very common, but I do want to get to the bottom of this crazy summation thing that I have. Okay. So we're going to get a minus 5n squared out from 100n minus 5n is 95n minus 10n is plus 85n. And the constant's minus 100 minus 100 is minus 200 plus 10 is minus 190. Oh, that's disgusting. But my idea is to take this simplified thing and set it equal to this thing. And hopefully n equals 6 solves it. Is this even a positive number? Has something gone terribly wrong here? It probably depends on the n, right? But for very large n, it's definitely negative, and that's an issue, because it should just be positive. I definitely did something wrong in all this. It does, it's a huge help if I don't randomly turn this plus into a minus, though, right? That's a terrible mistake to make. Wow. So that becomes plus 5n squared. And then I have to fix the n's. So plus 100n plus 5n is a 105n minus 10n is 95n. Yeah. All right. See ya, Arav. Thank you for the question. This still isn't. This is a negative number for small n, and that's still wrong. It should be positive. What else am I doing wrong? This should just be a 1, shouldn't it? I made that a 10 prematurely. God, this is riddled with errors. So that's just 100 now. Okay, this seems more reasonable. Because that's positive for n equals 1 and on. Okay. God. Okay, so we get 0 as 5n squared minus 5n minus 100. Divide out of 5. That'll make this clear. Oh, this 6 does not solve this. I'm getting 5. That's so annoyingly close. Is there so... I wonder if I'm somehow counting starting from 0. That could be it. And we'd have to somehow know to translate this 5 into a 6. Or if I made another mistake somewhere. I feel like we'd have to know to make that 5 into a 6, to be honest. In theory, I might be counting from the. I think I'm counting from this row, to be honest. And I need to remember the time between 0 and 1. Lucas, the original problem is right here. What is all this? Oh, that's a. Oh, journal plus plus. Why is it being terrible? I probably need to make a fresh file. Anders, we got a Minesweeper. Hope you're doing well, Anders. Do that in a second. Shouldn't there be times t minus 2 for the policeman, not t minus 1? Play the Anders music. I don't have it. I'm starting from t equals 2. I don't think so. Oh, maybe you're right. It should be t minus 2. So I'm getting the first one is 110. Yeah, Axel, that's a good point. The first term in this summation is 110, and it should be 100. I did do something slightly wrong there. Is EnigmaBot asleep? I can't fix that, unfortunately. I think Enigma would have to like restart it. Let's get the Minesweeper going. Go away. No, my fingers are cold. That's because my. Oh, no. We're starting a new one. How do you start a new one? There we go. It's not my fault. It's my cold fingers. Okay, that's what I'm blaming. Bam. 41 seconds. Yeah, is the bot not working at all? That doesn't seem like it. I know. I putting down flags just feels like a waste of time. Like I just shouldn't misclick. Now I do misclick a lot, but I can tell just at like a glance whether there's a mine or not there. So why bother flagging? Can I just mindlessly start this from t equals 1 and see what happens? How much lag? Oh, I don't know. How about this? I'll at the same time. Wait. I'm saying something, and I'm saying something in chat at the same time. I think that can measure lag. Okay. I do want to salvage this work because it's bothering me. Let's just brainlessly start this thing from t equals 1 instead and see what happens. Brainlessly, mindlessly, but also brainlessly. Um, Now? Oh my god. That's ridiculous, Anders. I don't know why you would have that much lag. I mean, I guess that's what I just did with Anders' chat there, but yeah. That's so weird. I'm not dropping frames or anything. Um, have I shown you the low latency thing? The setting on Twitch? Uh, if you haven't seen it before, Anders, in the settings on the stream, there is in advanced, turn on. I always use the low latency mode. It makes there be less lag. So if you don't have that turned on, you could try that. But that's like a lot of lag. So I don't know what will be causing that much. This comes from this problem. I solved it a brute force way with the table. It is on? Oh, okay. I don't know then. It's a problem that Arab asked over in the YouTube chat. And I solved it like brute force with the table, but I wanted to do it like a more elegant way. And so I was trying this summation thing based off the patterns from these columns. So I made the two summations and I intended to set them equal to each other. The issue is that when I did that, I didn't get 6. And the answer should be 6. So I'm trying to fix them now. I think for YouTube, some people have like even more lag than Twitch. Yes, the Coriolis effect. Hey, Tyler. Yeah, this problem really we should have accounted for the Coriolis effect. Put the text in Twitch chat too. So I was fixing this summation. That's just n. No longer -1. Now this is a teardown. I think that's okay. We don't get any constants from this, okay? Or a constant term. $95n. There we go. Okay, so set 100n equal to 5n squared plus 90. There's no way this gets a 6. All right. When the going gets tough, the tough give up. I don't know how you do this with summations. There should be a way. I just can't set it up right. I don't think. So, Axel, I thought I was doing basically the same thing by making it start from t minus 1 instead. Not me trying to figure this problem by counting my fingers. I mean, I that's what I did from it for the only way I could actually make work. Basically, counting on fingers. Should I start it from t equals 2 then and also make it t minus 2? Is this going to be the same thing or different? Okay, this work is too much of a pain to update every time. Let's just compress these steps. 100 n minus 1 from this term plus 10 times t, no, n plus 1 over 2 minus 1 minus 20 n minus 1? Question mark? I think so. (105n minus 20n). 85n? Minus 100 minus 10 is minus 110, plus 20 is minus 90. Okay, that's pretty similar to what we had before, and that was nearly right. Ninety divided by 5? 18? You just missed that alert? Fair enough. Hey, this is a n equals 6. Let's go. All right, good call, Axel. I couldn't. Well, I can sort of justify why. It's t minus 2. So we do know the first one should be 100. Triangular numbers? Well, I know like we are like summing integers here, but is there like somewhere else that you mean? You have to make dinner? All right. Thanks for saying hi, Anders. Enjoy your dinner. Oh, that's a cool emote. I like that. Noodles. Ooh. Okay. Um, I guess we'll go back to, unless someone has a different question, we'll go to I guess mechanics. I don't have anything lined up for linear algebra. Um, the answer is definitely six, Dojo. Yeah, it must be that starting speed. The hardest math I've done? Um, that's a good question. The so I think it's a personal question where I'm going to answer as the math classes I had the hardest time with. Other people don't find them nearly as hard, but I had the hardest time with my discrete math class, I think. Um, my second semester of physics was also rough. That's physics, and you're asking about math. Um, but yeah, my I'm just not a big fan of discrete math in the first place. But the professor who was teaching it was not very interested in teaching. Like I feel like he's more enthusiastic about like higher level math, and he should be teaching grad school or something, but he wasn't. Um, he's a cool dude, but just didn't seem too interested. Uh, so I don't know. That class was, and discrete math is already like a mishmash of a bunch of different types of math. That's the one I had the hardest time with. The most advanced one I did to answer the other interpretation is it's called methods of applied math, and we did a little bit of partial differential equations, a lot of systems of differential equations, and other things that I can't remember. But all this math, trying to find the. I don't want to go back to this physics. I want to go back to. I have still not fixed my work for this problem, and it's been at least a week. I think the answer part A and B are fine. I haven't actually checked them, but they seem okay. Part C, I'm getting into that don't make sense. And so I was just going to try doing this as the bounds for my integral. And I think that was potentially my issue. Because getting the signs right for x1 and x2 are kind of difficult. With abstract algebra and topology, I would have had a very difficult time with those classes if I didn't specifically avoid them. um, the preview classes I did were discrete math, a college geometry class. That might also be it. I didn't have to do analysis. I didn't have to do abstract algebra. My linear algebra class was very calculation heavy. So yeah, function analysis, that sounds hard. Because I don't know what function analysis even covers. Instead of doing absolute value, I don't want to deal with an absolute value. Let's just do negative x2. Infinite dimensional spaces using quantum mechanics. Okay, fair enough. Hey, Silverbird. Nothing with me. How about you? 3/4 mg 1/2 kx2 squared 1/4 mg x2 plus 1/4 mg x1 minus in x1 we know. Oh, this is a mechanics one that I'm working on. Globus the Elder, thank you for the follow. I watched your stream before. It seems cool. And sorry, I probably shouldn't call you out since you're just lurking, but welcome in. Um, sorry, but when you said "what's up, Silverbird," did you mean like literally what's above here? She wants to see the problem. um. Oh, awesome. Yeah. Shane rated here. So yeah. If you're interested in from what I've seen, Globus talks a lot about AI. So if you're interested in learning more about AI, go check him out. So I think I don't know if I responded to you. I got the answer for A and B. I haven't verified them, but they seem right. The answer for C has been eluding me. Is it separate reading? Oh, okay. It's hard to tell sometimes. um the answers I've been getting for part C don't make physical sense. So I'm trying to work those out. To work it out. Yeah, I'm good, Silverbird. I hope you are too. Did I not? Wait. Oh no. I never squared the x1. Ah, okay. I really hope those were my problem all along. I'm all right. Let's just send what I have now then. So it's gonna be 9/8 m squared g squared over k. This term comes from that times that, right? So I still need to carry down this term, and that's actually going to cancel. Fantastic. All right. Will we get an answer that makes sense? find out. This is so many constants. Over K. Please work out. I think the last time the units weren't even right. This time the units might be right. The units are right. 9/4 m squared g squared. Hey, this will clean up. That's a good sign. 9/4 is like 36/16. 37 over... Ugh. 37 is such a terrible number. We should just remove 37 from our number system. We don't need it. Hey, Raven. It's going good. How about you? "37 haters spotted." Yeah, you got me. mg/4k. Move for some math again? Nice. Famished. You'll love to hear it. Okay. This is a number, and it is a distance. I hate that we get the square root of 37. I gotta be honest. We do expect x2 to be a negative number with how we've defined things. And so I think I'm going to take x2 equal to the negative case. I don't feel that good about this, though. So Red has a question. Oh, Dojo's still trying with the other one. Let me look at Silver's question first, and then we can look at that. There's friction here, so the steady state will be no motion, but I'm interpreting it as when the mass is attached, the spring gets stretched whatever distance, x1 here. And the maximum compression they're asking about, I'm interpreting as the maximum, well, compression, as they say, like on the first compression. So what's the farthest to the left it'll get? It's how I'm interpreting it. And so since there's friction, it'll get the furthest left on the first bounce back. And that's what I'm attempting to calculate, that I may or may not have done right. Let's see what Dojo is saying about. Oh my god. I need to clean this PDF up about this problem. So you're getting 100t into 100 t minus 1, 5t minus 1. Oh, times t minus 2. Does that come out to be the same thing as me? I don't think I think I get a different thing still, Dojo. Maybe not. No. Do I? Yes? No? Yeah, I think I got it right. I'm trying to figure out if your thing is the same. Okay, cool. Spring force is equal to k delta x, so we need to anchor x1. Yeah. So I did this using energy, I guess, but I found in part A they ask you to get x1, so I found 3 over 2 mg over k. And so the starting position is it's stretched 3 over 2 mg over k. And then you let it do its thing, I guess, its spring thing. And so what I'm attempting for part C is the initial energy from that initial stretching should equal the spring potential from the maximum compression plus the work done by friction. So if I didn't do something disastrously wrong, which is highly likely, I think I'm getting that for x2. The reference point. No, I'm setting 0 to be the relaxed length. It is making it a little bit harder to deal with the sign of x1 versus x2. So that's why I expect x2 to be negative if the relaxed length is 0. So I just slammed a negative sign in front of x2 to hopefully fix that in the integral. It might have been better to define the 0 point from the like the x1, like from 0 to mg over k. Yeah, I feel pretty sketchy on that too, Fembox. It makes these spring potentials a lot simpler. But this integral is really weird. Yeah, I guess this is my 0 and positive x is that way, is what I was thinking. So kinetic energy 0, maximum compression. Yeah. So I may have set this up slightly wrong still, but that was the idea at least. I I think I feel good enough about this to check the answer. I would not be surprised if I still did something wrong though. So spoiler alert, but I think I'm gonna check the answer. Number 15. C is wrong. I'm not surprised to hear it. But I'm at my wit's end with it, I think. A is right, B is right. Write out the differential equation. It's not a bad idea. I wanted to use energy because that's what the chapter is about, but MGO, oh, come on. My X1 is 3/2, and it was just this thing here. It's just my friction term that's wrong, I think. No. Where is D measured from? Mu equals a quarter. If mu equals a quarter, I remembered it. Yeah. Uh, it's right there. It must be the bounds of my integral. Is D the distance from x0 to my x2, I guess? I can't tell from their phrasing. It must be that D is measured relative to relaxed length based off this being the answer. Or like, they just say that D is the answer. Um, Tertar x0 is basically the length at the end of part A, like how far it gets stretched to the right before you cut the string. And I think D is measured from the relaxed length to the compression as a positive number. I'm having a hard time being certain about that though. It must be. It's D. I shouldn't have worried about the sign of x2, maybe. I should have just let it be a positive number. Maybe that would have been simpler. I thought I couldn't make it a positive number. That's why I was doing all that weird stuff. I guess because I wanted the integral to be from x1 to whatever the endpoint is. I should have thought about it maybe as zero distance to x1 plus x2. You would have done it by forces. I don't know how you do it by forces. See, when there's like friction involved. Okay, with this edit, I think what I have is completely equivalent to the book's solution. Integrate. Oh, use the integrate the forces to get energy. Okay. Um, 3/8 m squared g squared over k. Nope. I have to subtract this thing off. And I want to get this term first. Three over 8 minus 9/8 is minus 6/8, which is minus 2/3, or minus 3/4. All right, let's send this. See if it works. How did they avoid the quadratic formula? I should have looked at that. This is wrong. Oh, we simply plugged it in wrong. AC. 4 times AC. This is right. Or is this closer to being right? Multiply everything by k, then factor. Oh, would that work? Would that maybe it would factor. I'm already in too deep here, but okay. 1 over 16 plus 3 over 2. 24 over 16. 25 over 16. That's a perfect square at least. 25 over 16 is 5 over 4. We already got this. And if we do minus, so the sign is confusing because we took x. I guess it's good because we took x2 to be a positive number. Well, I don't know. It would be hard for me to justify that. I said x2 should be positive. But we are supposed to get mg over k. Oh, okay. They avoid it by cleverly factoring out x naught plus d, I guess. And that doesn't give you any useful information. Yeah, maybe I'm thinking about x2 wrong. Maybe the way I'm thinking it's supposed to be isn't how the math actually would define it. I don't know. Or like, maybe it didn't define it the way that I thought I did. Hmm. YOLO. We'll just leave it. Um, I don't want to go back to 24 to be honest. I kind of want to grab a new one. Honestly, if I could think of a linear algebra problem to do, I'd probably do that. But I probably just need to start reading from a textbook. We'll just do 16. I don't want to deal with looking through a textbook. What is this? So there's no gravity. Why does anything happen? Oh, it's a kick. I have to read this thing multiple times. Hey, Change, how's it going? Bring in the height. The relaxed length of the spring is 0. Huh. The bead starts here. You give it a kick. Free body diagram for the bead. This is weird. So directly up, presumably we have K. Let's not quantify things yet. Spring. And it has to be perpendicular to the rail, the normal force. Like that? I don't like that the normal force is perpendicular, but it is the normal force. It is perpendicular by nature. Friction goes in the other direction? Well, wait. The bead is moving to the right, though. Shouldn't friction, if the bead is moving that way, should friction not be opposing the direction of movement? I mean, it's given just an initial kick. So it's not an ongoing force. It's going to have the initial kick, move out some distance, and then come back in, I guess. Okay. Sounds like you agree now. So it will change direction at some point. Depending on friction, if you're looking at part C, but As for the initial kick phase, that's where friction is going. I think. Oh wait, there's another part to part A. Where the force is all in terms of x. So x is that distance. No worries, it is a long problem, Territar. We're gonna need some trig for this. So spring force, kx sine theta. The normal force is opposing the spring force. But they're not in the same direction. So like that's wait. Does my free body diagram need to be tilted? The entire thing? Because the bead, well, I guess the bead could know it's at an angle. Here's our saying the normal force should be equal and opposite to kx cosine x. Plus for neither opponent of mg. There's no gravity here, thankfully. I just for the sake of my brain, I need to rotate this free body diagram from the bead's perspective. If I was standing on the bead, this rail will be the tilted one. Fs would be like that. Friction would be like that. Normal will be like that. This makes more sense to me. AP pre-calc? Yeah, sure. Retype your question there in chat or put it in my Discord. Sequences, I should be able to figure it out. This angle here is pi over 2 minus theta because it's this angle here. How does that help me? Because normal force is equal and opposite to the vertical component of the spring. Okay. And I think that's what you're saying that I should get, Territar. Like we need to get the actual stretch length of the spring. Very true. You're right. We're given in the prompt that that's a right angle there. The thing is, the spring can also move. We need trig, not Pythagorean theorem, I guess. X sine theta. This looks very janky. It is a thing though. The spring is always perpendicular to the rail. This part of the spring here can move left or right. Is how I'm interpreting it in order to make that happen. So what about friction? It's mu we're given for the kinetic friction times the normal force. I kind of hate the sine theta cosine theta thing. But it's what we get. So why is this x sine theta? Right, because that's the stretch length of the spring. And the normal force only cares about a component of that. You skipped algebra 2. You did good on your placement test. Oh, dang. Okay. So we're summing some series here. We were just doing something kind of like this. Let me... The way that I would do it probably isn't the best way. Let me find... Because that's the formula for an arithmetic progression, right? So what I'm noticing is that this is basically the sum of an I don't know if it's arithmetic series or arithmetic series. I don't know how you pronounce it, to be honest, but like the point is this formula here matches the exact thing we have in the problem. But conveniently, there's a formula for that sum. So let me bring this in. Okay, so the first summation they give us. Oh my god, not infinity. According to this formula here, we can also write this as 1/2 times capital N is the 12. 12 minus 1 is 11 times D. So that's what this summation is equal to based on the formula. But we also know that's equal to 630. So this is an equation with two variables. Now let's do the same thing with the other equation. Half times 20, 2a plus 19d. But we know this is 1770. So after applying the formula, we've just ended up with a system of two equations with two unknowns. And so we can solve this using any technique you're used to, substitution or elimination. Let me clean up both of these a bit and we can follow it through. So 1/2 times 12 is 6, and that 6 will get distributed to each of these. So if I name that equation 1, it becomes 12a plus 66d is 630. Let's keep working on this. Can we divide out a 3? We can. 4a plus 22d is 210. I see we can divide out a 2 as well, so let's do that. 2a plus 11d is 105. So I think that's the best that we can do here. In terms of getting in simplest terms, so let's do the same thing with equation 2. 1/2 times 20 is 10. Distribute the 10 to each of these. 20a plus 190d is 177. That's a little bit harder to simplify. I don't think we get any common things we can divide by here. These numbers are annoying, but we can do it. Oh wait, you skipped algebra 2. Maybe I shouldn't be. I don't know where the gaps in your knowledge are, but have you solved the system of equations where like 2x plus 3y equals 5 and minus x plus 2y is 0? Like, do you know how to find x and y if you have that? Yes? Oh, okay, good. We're doing the exact same thing with these two. So I have this equation and this equation, and we can use elimination to find a and d. So I'm going to eliminate a. We have a 20a here, 2a here. Let's multiply through equation 1 by 10. Times 10. Looks like that. And equation 2 just comes down as it is. Now we subtract them off. These two eliminate. 110d minus 190d minus 80d. 1050 minus 177 is a job for a calculator. $873. Wow. Did I do something wrong? This is such a terrible number. And it's negative. I did something wrong. Oh, this is 1770. I chopped off the 0. That'll do it. Yeah. So that's 720 negative. Okay, and that should go in. That's a positive number, which is a good sign. And that'll be just 9, not even 90. That's a reasonable number. So if d is 9, we can plug it into either of these equations. The first one looks a lot simpler, so let's do that. So 11 times 9 is 99. 105 minus 99 is 6. So A is 3. And so that's our answer. They asked us to find A and D, and here they are. D is 9, A is 3. So the key is to know this formula exists, and then solve out a system of equations. Yeah, I mean, I didn't have to learn. I never did AP pre-calc. It wasn't a thing when I was in high school. But I had never had to learn this formula as part of school, to be honest. What is an easy way to remember it? I'm not sure though. AP physics? I know some physics. Um, oh, that sucks. Someone who's good with AP physics is actual education though, especially. Does this command work now? No? Yes. He streams on YouTube also. He's like he dual streams on YouTube and Twitch. And he might be streaming right now, to be honest. He probably is. Um, so for physics in particular, he's a great shout, and for math in general too. And he does any type of math and science. So he's a good sub to have. Nice try, famished. Math fatigue, that was quick. Well, I don't know. Never mind. It's been a good few hours. I get fatigued too. He's also giving algebra 2 is ouch. That's true, territory. Yeah, that'll make it harder. Yeah, hydration can help. Speaking of, I'm debating if I want to try to. I don't. We got Zach's class in a little more than half an hour. I might just call it here because I don't think I'm gonna have time to do this physics problem. I was trying to figure out without notes or chat GPT. Oh. I think I am gonna call it here. It's always good to be able to figure stuff out without notes, but oh, Joshua, do you have a last minute question? Uh, yeah, this is quick. We can do this before I call it. This one is another form you just have to know, unfortunately. He said 25. So the sum of the geometric for an infinite, importantly, finite is slightly different. Let me write them both. So if you have an infinite geometric series, A is your first term, R is your rate. So in number 25, we start with 27, so that's our A. And each time we're dividing by 9, it looks like. Because 27 over 3 is 9, 3 over 9 is a third, and so on. I didn't write the actual formula, did I? If you have an infinite geometric series, the formula is A over 1 minus R. So for number 25, A is 27, R is 1 over 9, so we just plug and chug. The sum S is equal to 27 over 1 minus 1 over 9. Now I simplify it. 1 minus 1 over 9 is 8 over 9. And now with a fraction of a fraction, I'm going to take the bottom, flip it, and multiply it. Oops. So 27 times 9 over 8 now. And that doesn't simplify, does it? 243. over 8 is our answer. Annoyingly. If it's a finite geometric series, there's a different formula. You put 8 instead of 3? Oh no. Fur29, thank you for the follow. Welcome in. If the series is finite, meaning it ends at some point, then the formula is the same thing, but there's a 1 minus r to the n in the numerator. Yeah. I do think I need to call it here, though. I'm sorry you just got here and I'm about to call it, but I do have to get going. For anyone who's new around here, if you're interested in math streams in general, here's a whole list of them. Sounds good, Joshua. Look forward to seeing you again. So I'm gonna cut the YouTube stream off here. So Joshua, Territar, anyone here on YouTube, thanks for being here. I'll be back on YouTube in 2 days.